Hello again. In this video, I will be solving this new different circuit design where I will be finding or calculating the total resistor or the equivalent resistor between the two terminals of a battery. And after that, I need to find or calculate, determine the total current if the battery supply is 30 volt. Now, I will start with resistor 4 and resistor 5 are in parallel, and I will name it R equivalent 1. So R equivalent 1, we can use the advantage of R4, R5. That's a special way to solve it when it's only two resistor, and that will give me the value of almost 25 ohm. Now the equivalent of these two, which is in other way, it's kind of like I take these off and I have a new resistor here named R equivalent 1, and you can see it is connected with R6 in series. So R equivalent 1 and resistor number 6 are in series, and I will name the new equivalent of them as R equivalent 2. Now R equivalent 2 will be the adding of both of them, so 25 plus 75, that will be 100 ohm. Great. So we know that this region here, this whole region, or this branch, all this branch here being replaced by R equivalent 2, and the total is 100 ohm. Now I will start focusing my calculation on resistor number 2 and resistor number 3, which they are connected, R2 and R3 in series, and I will name their equivalent as an R equivalent 3. Okay, now because they are in series, we add them up, 47 plus 47, that will give us 94 ohm. Now from all this, I will end with a circuit look like this so far. I have R1, this one is R equivalent 3, this one will be representing R equivalent 2. Okay, so this is how it looked like our circuit up to this stage. So now we need to find the equivalent of R equivalent 3 and 2 because they are connected in parallel. So I can write down here R equivalent 2 and R equivalent 3. They are parallel, and their outcome, I will name it as an R equivalent 4. Once again, you could use the other way of the formula. So, okay, it's 2 plus 1 over R equivalent 3, and finding the inverse, or use the first way we did it before. That will give us total 48.5 ohm. Okay, that's the resistor. Now our circuit look like this. That's R equivalent 4, and this is R1, and of course we have our battery. And now we can see that resistor number 1 and the resistor equivalent 4, they are in series, and they will give me the total resistance, the resistors of the whole circuit, or the R equivalent for the whole thing, which is we just gonna add them up. R1 was 100 ohm, and the equivalent for number like 4, this one here, we just found it, it's 48. So 100 plus 48.5, that will be our final total resistance. It is 100, sorry, it is 148.5 ohm. That's the total resistance in this circuit, or the equivalent. So the circuit now, it's the simple circuit. It's going to be our battery voltage with R equivalent final, which is 148.5 ohm. Okay. Now the other part of the question is to find the total current if the battery provide 30 volt, which we can calculate by simply following Ohm's law. That's the voltage I R equivalent. So I will be the voltage. Voltage is 30 divided over 148.5. It will give us about 0.2 ampere. That will be the current going through, or the total current going through our whole circuit. And if we go to the original circuit from the start, that will be the total current will be spreading or shared between all these resistors. Okay? Well, this is one of the examples you can use to practice the combination resistors parallel series, and how you can find the equivalent. After that, you can apply it to find the total current going through this circuit. I hope you find this video useful, and see you in another one. Thank you.